You turn on the flashlight at the edge of the black hole. What will happen? Was the light swallowed directly or ran away around the corner? The answer is definitely beyond your imagination. You might see the back of your head, or you'll see the flashlight he split. This is not science fiction. This is a real phenomenon calculated by physics. But for different species of black holes, the effect is completely different. Yes, black holes are also divided into varieties. Conventional black holes have about the mass of a star. Some are so huge that they take entire galaxies. Stay in place. Others are the most mysterious type. Currently only exists in theory. Once found, will directly challenge our perception of reality. Simply put, black hole, it's not really a hole. It's more like a spatial dead not caused by an attractive force. In this area, even if you go in at the speed of light, you have to rest. This line is the event. You must never try to reach out and touch the line. Even if only a finger is stretched out, you'll never come back. Anything that passes him, material energy, even your distress signal, will always be part of the black hole. Hello, Earthling. I am an old horse. Although black holes are lazy, won't hunt everywhere, but we are diligent. The next 20 minutes, bring a flashlight. Let's see what's the difference between these black holes. Your first stop is a stellar black hole. Originally, scientists thought black holes usually started with stars. When the most massive star comes to an end, they won't go out quietly. They will be greedy and cause a powerful explosion. The light of that moment can even cover an entire galaxy. After this mess, what's left may be the first monster. Stellar black hole. But there is a threshold for forming a black hole. Not all stars are qualified to become black holes. For example, our sun is too small. He's not qualified to become a black hole. He will die more gently. Become a white dwarf. To create a stellar black hole, usually is a star at least 20 times the mass of the sun. Once such a star runs out of nuclear fuel, its core will lose support and collapse inward. Attractive force overwhelms all other forces, squeeze matter to unimaginable densities. The result is between 3 and 100 times the mass of the sun, but an object no larger than a city. Imagine that. Put a black hole only a few kilometers wide. What happens when stuffed into the core of the Earth? That's right, everything about our entire planet will be swallowed in an instant. That feeling, it's like taking the world's 7 billion population all compressed into a grain of sand. This is what we call density, but small and non-luminous objects. How to find? Don't even think about shining a flashlight on him. He can only look at their surroundings. Although the black hole itself is invisible, but the damage he did to the neighborhood will reveal his existence. When a black hole is paired with a half-star, he can steal gas from half-star. These gases don't fall directly into. Instead, it revolves wildly around the black hole first. Form an attack disk heated to millions of degrees. This strike disk will emit a strong X-ray. Generates enough signal robbers to reach Earth. By scanning the sky with an X-ray telescope, astronomer, to find these invisible lighthouses in the universe. Except for looking at X-rays, we can also use the attractive force itself to detect stellar black holes. If a star looks, get up and go round an invisible companion. Couple run and that significant other's mass is too large. Can't be an ordinary celestial body. Then the explanation is clear. There must be a black hole there. Perhaps the most famous example is Cygnus X1. He discovered in the 1960s, about 6,000 light years from Earth, one of the first confirmed black holes. Its core is a black hole about 21 times the mass of the sun, with a huge blue star, locked to each other in orbit. The system's X-ray radiation is so strong, can't be ignored. After decades of research, scientists conclusively prove Cygnus X1 indeed a black hole. This discovery is significant, even sparked an interesting gamble. Stephen Hawking once made a bet that Cygnus X1 will eventually prove to be not a black hole, but when the evidence is solid, he is willing to admit defeat. The attractive force is the most powerful force in the universe. Astronomers now think only in our galaxy, millions of stellar black holes may be scattered. Most are dormant, not devouring nearby stars, so stay invisible to us. They float quietly in the galaxy, unless we stumble upon the clues they left behind. Otherwise, it cannot be detected. Simply put, these black holes are the back of the universe, city-sized object with the weight of the sun. is the invisible city we can only find through shadows. Persistence and black holes are just the beginning of this journey. Next is the time to experience the ultimate universe. Second intermediate mass black hole. If stellar black holes are seeds, eventually grow into the black hole giant that rules the galaxy. So what's in between? Logic tells us there must be middleweight players. This is what astronomers call medium mass black hole. They represent the modern astrophysics, one of the most puzzling mysteries. In theory, they must exist, but the actual observations are completely different. We did find dozens of sun-heavy constant star black hole also saw the center of the galaxy, millions or billions of supermassive black holes the weight of the sun, but searching for decades in between. There should have been something weighing hundreds or black holes of thousands of suns, but so far we haven't been sure of any. Like all families, only grandpa and grandson, but no parents. They may be the missing link in the evolution of black holes. That is to explain small stellar black holes. How did it grow into? Key steps for supermassive black holes at the center of galaxies. No intermediate mass black holes. It's hard for us to understand how the universe builds its largest structure. So what do we know about them? Estimates show that the mass of an intermediate black hole should be between a few hundred and 100,000 solar masses. Compared to the titans at the core of the galaxy, it's small, but compared to its stellar cousin, it's unimaginable. Like putting the whole star, the mass of the mass compressed into something no larger than the moon. So this is where we're talking. The problem is, looking for them is like chasing shadows. Unlike a supermassive black hole as an inner star, light up the surroundings. Intermediate mass black holes are usually quiet and hidden deep. They don't devour large amounts of matter, nor is it always where we can. Easy to find convenient location. On the contrary, scientists must search for spiders in their presence. Silk Trail. A promising clue comes from a dense cluster of stars. That is, a tightly packed region of thousands of stars. If an unusually heavy object lurks in the center, he pulls the motion of the surrounding stars. By drawing these orbits, astronomers can sometimes deduce there is a black hole hidden there, like a globular cluster. Rhododendron 47 is a candidate, where the motion of the stars suggests may hide a mass thousands of times that of the sun. Quantitative object. Another clue comes from dwarf galaxy. It's a small galaxy on the edge of a large galaxy. Some of these weak systems seems to have neither stellar, not supermassive, but a black hole in between. A striking case is a galaxy called HLX1, about 290 million light-years from Earth. Astronomers think it contains about 20,000 solar mass black hole, almost a perfect example of a mid-quality category. We also pass ray flashes caught them slightly longitudinal, a fleeting glance. Occasionally, when an intermediate mass black hole devours a passing star, bursts of energy can be seen across space. These rare events may provide these hidden, one of the strongest proofs of the existence of giants. That's their mystery. Intermediate mass black holes may hold stars, the key to growth. But as we are in the star cluster, looking for them in galaxies and ripples in space and time, we may not only find out where they are, we'll also find in the universe how each black hole is born. The reason why I can't use a flashlight in front of me, mainly too small and too hard to find. Now is your chance. Supermassive black hole. How big are these black holes? Its mass reaches millions of the sun, even billions of times. Generally, they don't hide, but sitting at the center of the galaxy, shape and dictate the world around you. For example, the center of the Milky Way galaxy, 26,000 light-years from Earth, lies a monster known as Sagittarius. This black hole contains about 4 million solar masses, all squeezed into an orbit bigger than Mercury. In a small area, we can't see it directly, but we can track stars and orbit around the gas at breakneck speed. Some stars complete a circle in just a few years. The only explanation for this crazy movement is the invisible attractive force of a supermassive black hole, and Sagittarius compared to other black holes. It's mild. If you cover him with a flashlight, something interesting happened. Before falling into that dead line, there is a special orbit outside the black hole, photon layer. At this location, attractive force, the robber bent the light, or make photons like satellites circling around the black hole. So the flashlight you shoot forward circled the black hole and flew back, right in the back of your head. This is the black hole's gift to you. Let you not only see your own back, you can even see the entire universe around the black hole. Form distorted mirror. Except this one on our doorstep. Another famous behemoth is located in the galaxy M87. At his core, have a quality, a black hole 6 billion times larger than the Sun. In 2019, he became the World Telescope, the first black hole of the direct prime minister. That iconic photo, a glowing halo round dark shadows. The first time human beings see the edge of the abyss billions of light years away. To give you an idea of his size, if stellar black holes were the size of cities, then the supermassive black hole, bigger than our entire solar system. If you want to enter a black hole, they are the best choice. Although these guys look big and scary. But if you fall into this supermassive black hole, instead, you may not suffer so much because they are too big. Is to see the world far from the starting point of the center. So when you cross the border, the attractive force on the soles of the feet and the top of the head, you may have passed through without knowing it, until I find out that I can't go back. But the real problem is how these giants were formed. Stars and black holes are explaining the attractive force of stellar exploration, but not a single star big enough to be paralyzed, shrinking into something millions of times heavier than the Sun. So where do supermassive black holes come from? One theory is that they started with smaller black holes over cosmic time. By devouring stars, gases even merge with each other and grow. Another view is, in the early universe, huge gas cloud collapses directly into a black hole, completely skip the stellar stage. These black holes are not passive passers-by. Evidence shows that they're shaping the surrounding galaxies, play a central role. When matter falls, he can release enormous energy, powering what we call quasars. These bright beacons are so luminous, can even cover an entire galaxy. The outbursts of these quasars can drive strong winds, blow gas out of the galaxy, regulate star formation, and sculpts the evolution of galaxies. In this way, supermassive black holes are both disruptors, also a creator, and every large galaxy we observe. It seems that the core has such a giant. Without them, galaxies as we know them fall apart. But still not sure. Where did this giant black hole come from? Especially ridiculously large black holes, such as TON 618, if we follow the black holes we explore, are formed by stars or grown in galaxies. It's hard to explain. Why does such a big black hole appear? So new speculation emerged. Will some black holes be more constant than the stars are old, even older than the galaxy itself? If they were born after the Big Bang, what about the first moment? This is the concept of a black hole, a hypothetical relic from the dawn of time. Unlike stellar or supermassive black holes, these black holes are not the result of stellar exploration. Instead, they could be the universe. When born in less than 1 second, everything was hot when it was formed. Dense and chaotic. Tiny fluctuations in the structure of space may be highly concentrated, so that the attractive force crushes it into a black hole on the spot. If they exist, the size of the original black hole may be surprisingly diverse. Some may not be larger than atoms. Quality is based on customers. Other may be comparable in weight to mountains or even asteroids. Imagine one smaller than a grain of sand, but a black hole heavier than Mount Everest. This is the bizarre scale we face. But why do scientists question these hypothetical objects? The answer lies in one of the universe's greatest unsolved dark matter for decades. Astronomers observe how galaxies spin can't be explained by the matter we see. There must be some hidden quality, hold everything together. One possibility is dark matter is not made up of ambiguous particles, but by walking in the universe, made up of countless primordial black holes. If this is true, that means the missing mass of the universe, actually made in space, of invisible black holes floating quietly. Some theories even suggest that there may be trillions of such black holes pass through our solar system at any time, even straight through the Earth without leaving a trace, because their attractive force is too small, very small size. We won't even notice if there is such a black hole. Don't say jump in, you can't even feel his presence. This deepens the mystery. If primordial black holes formed in the early universe, they may also explain supermassive black holes. How did it grow so quickly? Observations show that less than 1 billion years after the Big Bang, giant black hole already exists. But stellar black holes, not long enough to get that big. A round black hole as a seed may have given them a huge first mover advantage. But so far the evidence is weak. We haven't directly observed any distant black hole. They are still ghosts in theory. whether they are real or not. The concept itself reshapes our imagination. It turns out, black holes may be more than just the end stages of stars. They may also be the first structures built by the universe. But the thing that most subverts your impression of black holes, not at all how old he is, but the ultimate small. Even smaller than an atom. This is a quantum black hole. This strange and highly theoretical concept, formed by the collapse of stars, or the black hole found at the center of the galaxy, is different. Quantum black holes belong to another frontier. They exist in our best scientific theories. Einstein's general theory of relativity and quantum mechanics. In spaces that overlap and start fighting, relativity explains how attractive forces shape the universe on a macroscopic scale, and quantum mechanics dominate the unpredictable world of subatomic particles. If matter is compressed to unimaginably small scale, both sets of laws apply. Can't fully explain. This is the Planck scale, where the concept of black holes comes into play. The Planck length is about 10 to the minus 35th meter. This is the smallest meaningful unit in space. According to physics, a black hole of this size would be unimaginably small, much smaller than protons, but still has a huge density. But there is a problem. Tiny black holes don't last. This comes from Stephen Hawking's theory. Let us know. A black hole passes through her. The process of Hawking radiation slowly evaporates for those big guys. When this evaporation is required, longer than the age of the universe itself, but a particle-sized black hole will evaporate in the blink of an eye, release its energy almost instantaneously, and then disappear completely. Can these tiny black holes really exist? Some scientists speculate they may have been in the early universe, under severe conditions with extremely high energy density, and some even worried. Like the Large Hadron Collider particle accelerator, the high-energy collisions it produces. Will it create a black hole? Don't worry, even if it's made. They disappear faster than they appear. Too late to devour the Earth. And a quantum black hole is a thought experiment, forcing physicists to confront science, one of the deepest mysteries. How to unify quantum mechanics and attractive forces. If you can prove that such an object exists, even if it's just fleeting, they will also contribute to the establishment of a theory of everything. But the journey to the black hole is not outside over these yet. Categories. Scientists also propose other fascinating black hole types. Like one of the most exciting discoveries in recent years, double black hole. It's a pair of black holes locked in orbit with each other. Billions of years. They're getting closer. Until the end, collide in a catastrophic energy release, and merge. When this happens, ripples will travel through the fabric of spacetime itself. We call these ripples attractive force waves. LEGO Observatory in 2015 detected them for the first time. That moment not only confirmed Einstein's prediction, also confirmed that in distant galaxies, existence of black hole pairs. But except for the black hole that can't get in and out, another theory of monsters that can only get in and out. White hole. It's like the opposite of a black hole. Nothing can get in. Matter and energy can only be expelled from it, although this remains firmly in the realm of speculation. But he has an interesting if. Captured our imagination. If all the matter swallowed by the black hole, but on the other side, erupting out in the form of a white hole. One last question for you. First, we shone a flashlight on the black hole. Then if you turn around and use a flashlight to illuminate the white hole, what do you think will happen? Time is bounced back directly, or... Welcome to share your brain hole in the comments section. I am an old horse. Good night.